Hi, I'm Alexandra Reyes,
And I'm Nicolette Hoffman.
and this is our final presentation to our venture partners at AGTC.
I'm gonna go.
So our third and final project was on color blindness. And this is just some basic background information on what color blindness is. It's basically when you have the inability to see colors as everyone else would see. And what happens in your eye is that the retina part, right here in the back, is missing either all the cones or certain cones. And depending on which cones it's missing, that's what kind of color blindness you will be. There are three different types of color blindness. There's red color blindness, green color blindness, and blue color blindness. And like I said before, every one of those differs depending on which cones you're missing in your retina. And this is just to visualize what different color blindness would look like. This is what normal vision looks like. Can you pronounce those?
Densitodia, chronopia, and trinopia.
And as you can see, these two are extremely similar, and actually in the next slide,
It'll go into more
Yeah,
detail. And then
break
you
it
can
down.
see how this one is completely different and you basically can't see anything at all.
So this just breaks down the differences between the two different types of color blindness that were similar in the previous slide. It just lets you know how in this one you mostly see black with shades of red, and that one you're actually able to see mid-reds and greens. And as you can see in this one, you see mid-greens with orange, and that one you can see like light blues, you see more pinks. So obviously in that one you see slightly different colors than in this one. And then in the third type of color blindness, the most common color confusion are light blues with grays, dark purples with blacks, mid greens with blues, and oranges with reds. Here we have total color blindness, and as opposed to what most people would think, you don't see in black and white, you actually see in different shades of gray. This is actually the most rare type of color blindness. And there's just some background information.
And we also conducted a survey for AGTC, and of the 15 people that we conducted, only one person was all colorblind. Also,
these are the different types of, these are the different causes of color blindness. The top one is hereditary, and that's actually the most common. We'll break that one down later on in the slide. The following ones are chronic illness, accidents, medications, industrial or environmental chemicals, and age. Behind just genetically getting the disease or the disorder, age is actually the most common one. As you get older, your vision just changes. And with all of the other ones except for the genetic one, your color blindness isn't constant. It sometimes varies. Sometimes you're colorblind. You might it might get worse or it might get better. You might be colorblind temporarily and then be cured of color blindness, basically. But when you genetically get it, you have it.
but there is no actual cure.
Yeah.
Just make me go.
This just breaks down inherited color blindness. Color blindness is passed from the mother to son, usually, and it's passed always on the 23rd chromosome, which is a sex chromosome. The reason why males, there's 7% of the population, 7% of males have it, and 1% of females is because since it's passed on the X chromosome, women are double X, so if one of the X chromosomes is mutated, the other one will make up for the mutation. On the other hand, males have XY chromosomes, so if their X chromosome is mutated, then they will be colorblind, with no doubt about it. And in the next couple of slides, there's actual family diagrams that break down different scenarios, like if the father's colorblind and the mother's not colorblind, what are the chances of the children being colorblind? This one is if the father is not colorblind and the mother is colorblind, the chances of the children being colorblind. if the father is colorblind and the mother is colorblind, the chance of the children being colorblind, as well as the chances of the daughters being carriers for the next generation. And then this one is father not colorblind, mother is colorblind. This slide talks about diagnosing colorblindness. Based on the research that we did ourselves with giving surveys to people that were colorblind, our candidates told us that they were mostly diagnosed between the ages of 6 and 12. Based on the research we had done online and everything, most children are diagnosed between the ages of 3 and 5. For the most part, everyone's always diagnosed during grade school because that's when they start coloring things and they realize that they're not coloring as they're supposed to or according to directions. And the way it's actually diagnosed is through a special type of visual test. It's not the normal vision test that they give out in schools. And in the next slide, it actually talks about the test. The test was developed by a professor at Tokyo University. And what happens is it's a series of about, as it says there, 24 plates, and you have to be able to see the color or either the squiggly lines in those plates. If you're not able to detect that there's even a figure, then you're colorblindness. And this test actually only detects red-green colorblindness. It doesn't detect blue-yellow. These are the different types of colorblindness broken down. Like we had said before, most men are colorblind. 1 in 12 men, which is about 8%, are colorblind, and 1 in 200 women across the world are colorblind. Red-green is the most common one. 8% of males are red-green colorblind, and only 0.5% of females are colorblind in red-green. Blue-yellow affects males and females equally. It's not connected to a sex chromosome. But this condition occurs in fewer than 1 in 10,000 people worldwide. And then even more rare than blue-yellow colorblindness, total colorblindness, it affects 1 in every 30,000 people across the world. And here we go into living with colorblindness. What we noticed from our survey is that most people that are colorblind just tend to adapt to colorblindness. They learn to memorize things. What we have here is actually based on our survey and also with research that we did. The common challenges they face every day are just cooking food, getting dressed, they mix up colors. Traffic signals, they tend to memorize where the green and red light traffics are. The weather tends to be an issue for a lot of colorblind people because they can't see the difference in the sky. They don't know if it's going to rain really because everything's just different shades to them. And we noticed that sunburn was a really big issue with colorblind people because they're not able to detect the change in color in their own skin, and they tend to burn because they stay out longer than they're supposed to. Some of the challenges in the workplace will just be like looking at the internet. The internet has a bunch of different colors that they're not able to notice, or they can't notice the difference between one thing and the other. Making PowerPoints, making presentations, charts, anything with a lot of color tends to be very confusing to them. And then the challenges they had in school, as we mentioned before, was just coloring wrong, or they couldn't see certain colors used on the board. And we actually have a video for that, but it's a little too long. So these are career restrictions that colorblind people face. So the first one, there's a driver, and that's because of the traffic signals. The second one is a pilot. Actually, if you're colorblind, to a certain extent, you can be a pilot. After that, there's no chance you become a pilot just because of all the control board has a lot of colors. And if you want to go into the military and be a pilot, you cannot be colorblind at all. Electricians can't be colorblind because of the different colored wires. Firefighters can't be colorblind because their equipment is certain colors for reasons. Yeah. And then the reds on the fire tell them different temperatures, and it's dangerous if they can't tell the difference between how intense the fire is. Baggage handlers, a lot of their stuff is color-coded, so they have to be able to differentiate between different baggages that are going onto different planes. police officers, if they're given a description about a suspect and they use, for example, that the suspect is wearing a red shirt, but they're colorblind, that's not gonna help them at all. They're gonna have a very hard time finding who they need to find. Painters, just because of all the colors used when you paint. And then chefs, because you can't tell when the meat's cooked. You can't tell what the food color is, if it's bad or if it's so ripe and everything. So yeah, these are just some of the restrictions. And next slide is, these are the treatments for colorblindness. There is no cure for colorblindness. Our venture partners actually, the reason why we did this project is because they want to somehow find a cure for it. But first they wanted to do background research to see if it was even worth going into that field. People that are colorblind, they tend just to live with it. They don't look at it as a disease. It's more just of a disorder and an annoyance almost. They tend to use special eyeglasses and contact lenses to help with their colorblindness, but they still can't completely see in color. And they just basically go about their lives memorizing things and being extremely organized so that they know which things are what color, if the color is important in whatever they're doing. And I believe that's it. That's the end. So, thank you very much.
Thank you.